right, so here's number 10 on the practice test. We have to simplify a complex fraction and find the domain. So one thing that helps me with complex fractions is to write it with like a division symbol. So this is the same thing as 1 over x minus 1 over x plus 1 divided by 1 over x squared plus 2x plus 1. Now normally we should always get a common denominator first here and then flip it to multiply. So let's flip and multiply. So this would be just times x squared plus 2x plus 1. And we could actually just distribute this in and simplify it that way. But let's just get a common denominator anyway, since that's the process we normally use. So I'll multiply this by x plus 1 over x plus 1, and this by x over x. So it becomes x plus 1 minus x over x times x plus 1. And I'm going to keep the denominator factor. So if I simplify this a little more, this numerator just cancels out and becomes 1 over x times x plus 1. And then times this, which factors to x plus 1 times x plus 1, all over 1. So now if I multiply across, I get x plus 1 over x plus 1, because it's times 1, over x times x plus 1. And this cancels out, and I'm left with x plus 1 over x, where my domain is x can equal 0, because then we'd be dividing by 0. But it also can't equal negative 1, because before we simplified this, before we canceled it out, we canceled out the factor of x plus 1 over x plus 1. And if we plug negative 1 into that, it would be 0 over 0, which isn't 1. 0 over 0 is the only time you have a ratio of two numbers that are the same where it doesn't equal 1. It's an indeterminate. It's indeterminate. It's not a real number. So a good rule of thumb is you check for domain before you simplify, right? Or even go back into the original equation, and you can see that x can equal 0 because of this right here. And x also can equal negative 1 because of this and this, which factors x plus 1 times x plus 1. The reason why is because this expression here should yield the same exact results for whatever you plug in for x for the original. So no matter what I plug in to this simplified part, I'll get the same value as if I plug the same x value into here. But the thing is, if I plugged negative 1 into this, I would get a number. I would get 0, which is a real number. But I wouldn't get a real number if I plugged it into the original, which is why I have to take negative 1 out of my domain. So this right here is your final answer.